compound interest. Let's calculate it. Okay, so first thing before we get into actually calculating compound interest, we need to talk about this here formula. So to the right in my beautiful handwriting, you're going to see a formula. A equals P times the quantity, 1 plus R over N, that's an N, raised to the N times T power. Now, I say NT and I think Ninja Turtles. I don't know what you guys think about, but that's what I think. Let's talk about what these letters mean. So that A is the balance after all of the years that we collect this interest, and T is the year. So balance after T years. The P is the starting principal. So the amount that you put in, you deposited at the beginning, whatever, that's the P. The R is the interest rate. This is the annual. Usually it's called the APR, the annual percentage rate. And we will change that to a decimal. N is the number of times we compound in a year. And as I mentioned, T is the number of years. Now let's back up to N, the number of times we compound in a year. So if we compound annually, that's once a year because annual means 1. If I say quarterly, there are 4 quarters of a year, so N would be 4. Monthly, 12 months in a year, so N is 12. Daily, 365. There could be others, but those are the 4 main ones. Okay, so let's play a little bit here. Barry deposits $600 into an account that earns 3.5% interest compounded annually. How much will he have after 12 years? Now, we are assuming that there's no other activity, so no deposits, no withdrawals, no nothing. Just money's in there, collecting interest annually. So, using our formula, here we go. A equals P, 1 plus R over N raised to the N times T. Now, when I plug our values in, we're trying to find A. The principal is what we start with, 600. Inside, I have 3.5% as a decimal. Annual, again, is 1, so N is 1. And then we raise it to the 1 times 12 power. Now, I'm going to go ahead and simplify this before we start talking about calculator business. So A is 600 times 1 plus 0.035 raised to the 12th power. Now, you have to remember to do order of operations. They're a thing, and they matter. So we go inside the parentheses first. So 600 times 1.035 raised to the 12th power. Now, you're going to do the exponent. So 1.035 raised to the 12th power. Now, this is going to give you a really ugly number. Okay, so that gives me 600 times like 1.511, blah, 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 blah. You want to keep that in your calculator and then just hit times 600. So our final answer will be something like $906.64, rounded to the nearest penny. So that's an ugly looking 9. Let me fix that a little bit. So if Barry puts this $600 in the account and leaves it for 12 years, it'll grow to be $906.64 after 12 years. Great, wonderful. Now, I want to do the same basic example, except let's talk about Lamar, but $600, 3.5%. The difference is I want to compound monthly. We're still talking 12 years. Just so you can see with the exact same numbers, how does the difference in compounding change the value? Okay, because it does. So A equals 600, 1 plus 0.035 divided by 12, raised to the 12 times 12 power. Because remember, we have N is 12 because it's monthly, and we have 12 years. That's where we have the 12 times 12. Okay, now with our order of operations, inside the parentheses, we have to divide first. And this is ugly, you guys. When you take 0.035 and you divide by 12, it's a really, really ugly decimal. So we're going to take that ugly decimal and we're going to add it to 1. So I get 600 and then 1.0029, blah, 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 keeps going. And we're going to raise it to the 12 times 12 power, which is 144. Now, in your calculator, you should still have this 1.0029, blah, 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 blah. So we're just going to hit the caret button and raise that to the 144th power. So now I have 600 times 1.521, blah, 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 and then we hit times 600. So the nice thing about your calculator is it keeps all the decimal points. So you never have to round. You just keep those numbers in and you just do the next step in your order of operations. So if we go back to this very first spot where you would take 0.035 divided by 12, enter, plus 1, enter, raised to the 144th power, enter, times 600, enter. Every time you just have to hit enter and it'll take you to the next piece there. So I have $912.62. So you'll notice in our first example, we had 906.64, and now we have 912.62. I know that $5.98 doesn't seem like a lot. And over the course of 12 years, it's not all that much. It's like 50 cents a year. But if you think about this in terms of more money, what if you deposited $10,000 and you let it sit, right? The more, obviously, the more you throw in there, the more it's going to grow. But the more times we compound, the more money we're going to have. And that's because every time we compound, this is why it works. Every time we compound, so after that first month, the interest that you make gets added on to the balance of 600. So the next time we find the interest, what we're calculating on has grown a little bit. So every time, so the more times you compound, that gives your beginning amount more time to grow. I don't know if that makes any dang sense or not, but that's the basic idea. You want your money to compound as many times as possible because every time it compounds, it gets bigger, and that's what we want. Yeah, there you go.